Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session we're going to be talking about fuses and earthing. Right, so what is a fuse? It's this, that's what it looks like in real life, and it's basically a very thin wire that if the current becomes too high, the wire will melt. So it's a thin wire, put this down, a thin wire. Yeah, so it's a thin wire that will melt if the current is too high. Yeah, so it's a very thin wire. If the current is too high, that wire will melt, therefore disconnecting my circuit. Okay, so which type of fuse do you use in each device? It depends on their fuse rating. So the fuse ratings are usually 3 amps, 5 amps, or 13 amps. This tells you the maximum current you can put into it. So those tell you the maximum amount of current that you can put into it. Let's say, for example, fine, I'll give you a couple of values. So let's say you have your mobile phone, I don't know, and it uses 2 amps. So 2 amps is in your mobile phone. Which fuse you select? You have to select the rating higher than it. So I would select for a 2 amp device. If I have a 2 amp device, I will select the 3 amp fuse. Yeah, so you always choose the value greater than it. Right, so I can't even write that down. 2 amp device, this is much better now. Device. I need a 3 amp fuse. Okay, now scrolling down. Test your understanding. Your mobile phone uses 3 amps of current and your hairdryer uses 6 amps. Which fuse should you select for each device? So, if I've got a 3 amp, well, let's do the mobile phone first. So if I have the mobile, it's going to have 3 amps. Which one do I choose? 3 amp, 5 amp, or 13 amp? I can't select the 3 amp one. Why? It will blow the second I connect it. So I have to select 5 amp fuse. I have to get the rating above it. Yeah, don't put the 3 amp one into a 3 amp device. It will blow when you connect it up. Right, what about the hairdryer? So let's go for hair dryer. For the hairdryer, I've got 6 amps. Therefore, if it's 6 amps, which one do I select? I can't select 3, it will blow. I can't select 5, that will also blow. So the next one up, it's the 13 amp fuse. And that's simple stuff here. Right, okay, let's move on. Let's go for the next bit. So, the next part of the course is, what is the earth wire used for? So what on earth is the earth wire used for? So here is my wonderful art skills. I've drawn a toaster on this side here. Yes, that's a toaster. Let's label that. Toaster. Yeah, that's a toaster. And there's some toast inside, at the top of my toaster. Right, so how toasters work is they have a wire bringing charge into the device. Then you have this thing over here, this squiggly line. This is the heating element, which obviously heats up, which therefore heats the bread. And then it runs back to my plug via the neutral wire. So the live wire is still going in, and the neutral wire brings the charge back again. This is all working fine, the first diagram. But now we have the following problem. What happens if the live wire becomes loose? So here's my second diagram, look at the bottom. If the live wire becomes loose and touches the metal case. So this is the problem now. So the problem, if live wire touches metal case, that's the problem. What's going to happen? So if the live wire touches the metal case, we know that the charge won't be going into the heating element and back again. It will be building up all over the device. Oh dear. Now, that's obviously going to mean that the device will become completely charged. If the device becomes completely charged, if you touch it, you'll receive electric shock. So that's not going to be an ideal scenario. So you've got to remove the charge from the outside casing. So let's try and the way we can do that is by connecting the earth wire. So very cleverly, if the earth wire is connected over here, this is the earth wire. So this is the earth wire. Why is it over there? It's so that, let's just, all the charge now won't build up around the case. It will flow all the way. It won't be able to build up on the case. I've gone too far. It won't be able to build up on the case. It will flow all through the earth wire back down to the plug. So all the charges now move back down into the plug. And yeah, make sure we understand that. So the charges, instead of building up around the case, are now moving through the earth wire back down to the plug, and in the plug the fuse will blow. So this leads to the fuse blowing. So let's write out the whole thing. So the problem at the start was, if the live wire touches the metal case, becomes loose, what's going to happen is, first step we said, the case will become charged. Case becomes charged. When the case becomes charged, that's obviously going to be dangerous for us. So the solution is, the earth wire will redirect the current back to the plug. Earth wire will direct the current back to the plug. And therefore, when it reaches the plug, the fuse will blow. Therefore, the fuse will blow. It's quite tough, not going to lie to you, that's quite tough. So let's underline the key points here. Live wire touches the metal case, the case becomes charged. The earth wire will direct the current back down to the plug, therefore the fuse will blow. Right, tough times, but you know, get your brain thinking. Now let's scroll down for the summary for this topic. Summary. The fuse and earth wire are both safety features for electrical circuits and plugs. The fuse is a very small thin wire which melts when the current is too high. If the live wire becomes loose and touches the metal case, the case will become charged. Do you want the case to become charged? No, you don't. So all you're going to do is you're going to redirect that current back down to the plug. And the reason why it chooses the earth wire is because the earth wire has minimal resistance. And then finally, this will cause the fuse in the plug to blow. Yeah, quite a lot to take in today's lesson, but a lot of it is just, it's a bit logical. Make sure you're happy with this diagram here. It's kind of tough. A lot of kids get confused with what's going on. You have to just identify where's the charge going in this scenario. And that's it for today. I shall see you next time for more GCSE physics. Goodbye.